Look at this question. A transverse wave along a string is given by y is equal to 2 sine 2 pi into 3t minus x plus pi by 4, and where x and y are in centimeters and t is in seconds. The acceleration of the particle located at x is equal to 4 and t is equal to 1 is. So you have been given an equation of wave and you are asked to find out what is the acceleration of the particle at a particular location and at a particular time. Acceleration is equal to minus omega square y. Y, you have to write this 2 sine 2 pi into 3t minus x plus pi by 4. This whole thing is an argument, okay? This whole thing, this 2 pi is only for this term. It is like this, okay? And square bracket. Now here we have to find the value of omega. So what is omega? Omega is the coefficient of t. So what is the coefficient of t? 6 pi. So omega is equal to 6 pi. Okay. Compare with the standard equation, you get the value of omega. And at x is equal to 4 and t is equal to 1. Put over here, what are you going to get? Acceleration is equal to minus 6 pi whole square multiplied by 2 into sine of, put t is equal to 1 and x is equal to 4. So 3 minus 4. Alright. So minus 1 minus 2 pi. Minus 2 pi plus pi by 4. How much? It is sine of 135. Right? You will get sine of minus 135. Sine is an even function. Sine of minus 135 and sine of 135 is same only. So what is this value? This is cos 45. Sine of 90 plus 45, cos 45. So this is minus 36 pi square into 2 into 1 by root 2. You are getting minus 36 root 2 pi square. Option 3 is the right answer. Second question. The velocity of a transverse wave in a stretched wire is 100 meters per second. If the length of the wire is doubled and tension in the string is also doubled, the final velocity of the transverse wave in the wire is. So it is like this. You have a wire of some length L and now it has been doubled. Wire length got increased. So initially in this wire, the transverse wave you had is 100 meters per second. What is the speed here? Now tell me, if the length is doubled, will the value of mu will change? What is mu? Mass per unit length. Okay, when you are increasing the length, mass also will increase proportionately. So our v is root over t by mu. So here mu is constant. So v is proportional to root t, or v1 by v2 is equal to root over t1 by t2. Okay. So the first velocity is given as 100. So we'll write it like this. v2, let us say, is the final one, and v1 is the initial one. So 100 by v is equal to initial tension was T and the final tension is 2T. Okay, the final tension is 2T. So here what are you getting? 1 upon root 2, right? So V is equal to 100 root 2. So root 2 value is 1.414, 100 into 1.414, 141.4 is the answer. See this question. A transverse wave propagating on a stretched wire of linear density 3 into 10 to the power of minus 4 kg per meter is represented by the equation y is equal to 0.2 sine of 1.5x plus 60t, where x is in meters and t is in seconds. The tension in the string is. So we have to find the tension in the string. See, what is the speed equation? One is root over t upon mu, where t is the tension and mu is the linear mass density. There is one more definition. It is equal to 1 omega upon k. This portion is called phase velocity. Okay, just remember that. Derivation not required. So here, what are we supposed to find? We have to find the t. So squaring both sides, equate these two. So it will be omega by k whole square into mu. Now omega is the coefficient of t. So it is 60 divided by k. K is the coefficient of x. You have to compare this with the standard equation. Y is equal to a sine kx plus omega t plus phi. This is the standard equation. So k is the coefficient of x, omega is the coefficient of t. So here this is 1.5 whole square multiplied by mu value is given as 3 into 10 to the power of minus 4. So this is 4, 4 square is 16, 16 into 3 48, 48 into 10 to the power of minus 4, you will get in newtons. Okay, did we take the units properly? So this is 60 divided by 1.5, this is 4 times 16 into 348 into 10 to the power of minus 4. So you are getting here 0.0048. Options are not matching, but this is the way you have to do it. Option 2 has to be right. Just check if I have, maybe this is in centimeters, y is in centimeters, let us just check that. If y is in centimeters, then this has to be multiplied with 100. Yeah, so this has to be multiplied with 100. So this whole thing has to be multiplied with 100. So you will get 0.48. Okay, option B is the right answer. In this question, what is the phase relationship between displacement, velocity and acceleration in a simple harmonic motion? Okay, so our general equation for y is equal to a sine omega t, right? When you differentiate this, you get velocity is equal to dy by dt is equal to a cos of omega t into omega, right? So this can be written as a omega into sine of omega t plus pi by 2. Okay. Acceleration, it is dv by dt. So if you differentiate this, you get minus a omega square sine omega t. So this can be written as a omega square sine of omega t plus pi. Okay. Sine of 180 plus theta is minus sin theta, and sine of 90 plus theta is cos theta. Right? Alright. So if you want to know the phase difference between displacement and velocity, look here, the phase difference here is pi by 2, because this can be written as a sine omega t plus 0 by 0 is the phi initial phase. So the difference between velocity and displacement is pi by 2. Omega t cancel, pi by 2 minus 0, pi by 2. So the phase difference between displacement and acceleration, this is 0, this is 180, this is pi, you know. So it is pi. The phase difference between velocity and acceleration is equal to, this is pi by 2 and this is pi. So it is pi minus pi by 2, it is pi by 2. These three values you should know. Okay, this is a small derivation for that, but this result you should know. In an experiment, it was found that a string vibrates in n loops where a mass m is placed on a pan. The mass that should be placed on the pan to make it vibrate in 2n loops with the same frequency, you can neglect the mass of the pan here, is. How much mass has to be added to that? No, it is like this. There is a string. On top of it you have put a mass. Alright? A mass m. Obviously what will happen? Let us say it is fixed here and here. So obviously this will vibrate. Right? This will vibrate. So initially what happened is, it vibrated in n loops. Okay? So for simplicity purpose I am taking, let us say, one loop. Okay? Now what happened? It is making 2n loops. So each loop got doubled, right? So let us say this is node to node and this is my lambda. So here also it is node to node. See, this is my length, okay? So here what is happening? This has become lambda now, new lambda, right? So your original lambda became lambda by 2 here. So the expression for velocity is root over t by mu. Okay. There is also an expression for velocity which is n lambda. N is the frequency. Alright. So we have two expressions for velocity. Now, if you take the tension in the string, okay, the tension in the string is proportional. The tension here I have drawn it horizontally, but it is suspended like this. There is a mass m. Alright. Now you are increasing this mass, so obviously there will be some vibration in the wire. So what is the tension here? If you draw the free body diagram, the mass is acting downwards, the tension is acting upwards. So the tension will be equal to the weight. Alright. So we can equate these two. You get n lambda is equal to root over t by mu, but t can be written as mg by mu. Alright. So this is the final expression we are getting. Now when he is adding the weight to here you have to neglect the weight of the pan. There is a pan here, you are adding a mass into it. We are taking into consideration only the mass, we are not taking into consideration the weight of the pan or the mass of the pan. So here what happens? The frequency has to be maintained. Okay, so if I write this n1 lambda 1 is equal to g by mu is a constant, so I am ignoring that. Okay, is proportional to mass. N lambda is proportional to mass. So here, what are you getting? You are getting g by mu is a constant. N lambda is proportional to the root of mass. So can we write like this? N1 by lambda 1, N2 by lambda 2 is equal to m divided by m dash. So here the frequencies have to be same frequency. N1 and 2 cancels. So lambda 1, if it is lambda 2 is lambda by 2 equal to root over m divided by m dash. So this becomes 2 is equal to root over m by m dash. Squaring both sides, you get 4 is equal to m by m dash, or m dash is equal to m by 4. M dash is equal to m by 4. Okay? Option B is the right answer. If the length of a stretched string is shortened by 40% and the tension is increased by 44%, then the ratio of the final and initial fundamental frequencies is. So you have a stretched string, let us say both ends are fixed. So its fundamental frequency is V upon 4L. Okay, we have seen this derivation also. So you can say here that N1 by N2 will be V1 by V2 into L2 by L1. Right? But V is proportional to root over T. So V1 by V2 will be equal to T1 by T2. Therefore N1 by N2 will be equal to root over T1 by T2 into L2 by L1. Okay. So now let us come to now tension is increased by 44%. Let us say the initial tension was T. Now the final tension T2 is increased by 44%. If it is increased by 50%, you will write 1.5 T. Increased by 44%, 1.44 T. Over 100, 44% has been raised. Over 1.44 it has become now. Okay, 100 plus 44 by 100. Okay, 100 plus 44 by 100 it has become 44% increase. And the length is shortened by 40%. Let us say original length was L, the final length will be 40% reduced. That means 60% remaining. So it is how much? So it is 0.6 L. Right? all put all those values here. So this becomes n1 by n2 equal to root over t1 by t2. So t1 is t and t2 is 1.44 t. Okay. Outside L2 by L1. L2 is 0.6 L divided by L. Okay. So tt cancel here. 1 divided by root over 1.44, it is 1.2. So it is 1.2 into 0.6 LL cancel. So this is 2 times. N1 by N2 is equal to 1 upon 2. Okay. Or N2 by N1 if you take, it is 2:1. Option 1 is the right answer. The fundamental frequency of a stretched string with a weight of 9 kg is 289 Hz. The weight required to produce its octave is, octave means, octave corresponds to the frequency which is double the natural frequency. If n is your natural frequency, 2n will be the octave. Okay. Now n is equal to, I am assuming both ends are fixed. So if both ends are fixed, the string length is constant, right? So n is basically v upon 4l, assuming both ends are fixed. N is constant, so n is proportional to v. But v is root over t by nu. Material is same, so v is proportional to root over t. Now we have seen in the previous question that t is equal to mg, right? That means t is proportional to m. So v is proportional to root m. That means n is proportional to root over m, right? So we can write here n1 by n2 is equal to m1 by m2. So n1 is given as n and n2 is 2n. m1 is given as 9 kg, right? This value doesn't make a difference because basically we are dealing in terms of ratios. So this is root over m, so root over 9 divided by root over m, let us say. So this is 1 upon 2, root 9 is 3, 3 into 2 is 6. So root m is equal to 6, m is equal to 36. Option D.